After you have estimated the base area, now you need to design for the moment resistance of the pad foundations. These are the formulas that you can use to determine the amount of reinforcement bar. You will need to determine the moment acting along the surface of the columns, which this moment will be on the basis of the ultimate limit state. With that, you will have to determine the stresses acting on the foundations by using this formula. The N here is with the factor of safety of 1.35 and 1.5 GK and QK respectively. The A here is determined based on the size that you have proposed. The M is the ultimate moments acting on the member. And the Y and the I has already been calculated in your previous calculations. Based on the equation here, you will get your ultimate stress at 180.4 kN per meter square and 60.8 kN per meter square. Now you will need to determine the bending moment acting at the column face. Referring to the stress diagram here, you need to determine the stress at the column face. This is determined by doing the interpolations to the positions of the column face, which is found to be 171.6 kN per meter square. This stress is required for you to determine the moment acting at the column face. From the trapezoid shapes of the stress here, it can be separated into two components, which are the rectangular shapes and the triangle shapes. Find the resultant stress due to the rectangular shapes on the basis of 171.6 kN per meter square to be multiplied with the lever arm to the column face. That will give you the moment due to the rectangular shapes. And then find the resultant force of this triangular stress, which is located at 2/3 from the face of the columns. The resultant force to be multiplied with the lever arm here will give you another moment. The summations of moments for both will be equivalent to your moment acting on the surface of the columns. Your moment at the longer span is conservatively determined on the basis of 171.6 kN per meter square. It is to be multiplied with this area here to get the resultant force, and that resultant force is to be multiplied with the lever arm, which is half of the distance from this length, which will give you the moment YY in these directions. Now you will have to determine the depth of the reinforcement bar from the top surface of the foundations. The main reinforcement bar will be longitudinal to the longer span, while the secondary bar will be transverse to the longitudinal bar, which is at the shorter directions. These are the formulas for you to determine the depth of the reinforcement bar. Now, based on the moments acquired, substitute into the formula here. This includes getting the K, checking whether it is less than 0.167, substituting the K into the Z here. Then you obtain the Z greater than 0.95. You will use Z equals to 0.95D and that would be your Z. Next, you will determine the amount of reinforcement bar based on this formula. You require 15 Y 16 bar for you to have AS provided greater than your AS required. Based on the amount of reinforcement bar obtained, check for the minimum and maximum area. These are the formulas to be used, and you found that the minimum area is less than the provided area. That means the provided reinforcement bar is adequate. And you also found that AS maximum is greater than AS provided. The reinforcement bar provided is also adequate. Next, you design for the transverse bar. Repeat the calculation step. Now you have your MYY equals to 380.1 as calculated earlier on. And you find your reinforcement bar with 25 units of Y12 here, which is greater than the AS provided. Check with your AS minimum and AS maximum. You will find the provided reinforcement bar is adequate.